Good to everyone. I am Brinda Shalini, Assistant Professor, Electrical and Electronics Engineering, Rohini College of Engineering and Technology, Palkulam, Kanyakumari District. For in this topic, we are discuss about the Unit 2, Real Power Frequency and Control. First topic is Unit 1. So first we are discuss about the what is mean by load frequency control for introduction. The difference between the generated power and instant load demand causes changing the nominal system frequency at the normal state. If the amount of generated power is less than the demand amount, speed and frequency of the generator begin decrease. Hence, the amount of protection of synchronous generator is made since frequency deviation occurred in the power system in order to maintain the balance. The frequency normally vary from 5% between light load to full load condition. In the change in load taken by the two machines running in parallel, if the change in the load S1 or S2, if the generation of S1 is alone it regulated to adjust the change as to have the constant frequency. The method of regulation is known as a flat frequency regulation. The other way sharing the change of the load is both S1 and S2 would regulate the generation to maintain the frequency constant. This is called parallel frequency regulation. All the generator is such as area constitute the concurrent group. So all the generators speed up and slow down the together maintaining the relative power angle. Such an area is called as a control area. The boundary of the control area will generally coincide with that of individual electricity and board company. What is the effect of change in frequency? So the AC motor analyzes speed is directly related to the frequency. The speed and the induced electromotive force varies because the change of frequency and the power. When operating the frequency below 49.5 Hz, some types of steam turbines rotor undergo the excessive vibration. The change in the frequency can use small operation of power converter by producing the harmonics. For power station running in parallel, it is necessary that the frequency of the network remain constant. Many devices connected to the grid only for work properly when the input frequency is the certain range. Next, it is globally economically optimum to keep the grid frequency with a small range. The inductance of the inductive elements are chosen based on the switching frequency. Changes in the frequency will cause disturbance in the output, may even cause a supply control. Next we discuss about the load frequency of single area system. For single area system, first we can generate the turbine model, generator model and the transmission line model. So this is a single load frequency control of single area system for load model. First one is governing turbine and load model. There are the three elements are connected in series. One summing point PCS and output del F of S is feedback element 1 by R is connected to the PCS. For steady state analysis of single area system, it can be divided by the two cases. First one, the speed changer can be fixed del BC equal to 0. So the load demand changes. This is called free governor operation. So del F equal to minus 1 by D plus 1 by R into del BD. For consider the step change in speed governor setting and the load demand remains constant. So del BD of S equal to 0. Del F equal to 1 by D plus 1 by R into del PC. Thank you for watching this